Today I'm going to walk you through my data analysis project on Vancouver's street trees dataset. This dataset provides a bunch of information about the city's urban forestry. And my primary goal was to uncover patterns and trends that could help inform decisions about urban greening. So let's dive in. First, I define the possible questions of interest. These questions are: what are the most common tree species in Vancouver and how are they distributed across neighborhoods? Are there trends in tree planting over time? And how do tree characteristics vary across neighborhoods? So as you can see, I provided the brief information regarding every column to understand what data we have. So it's location information, tree attributes, planting details, streets and infrastructure features, and some other columns. Then I started by loading the dataset into pandas and inspecting the structure using head, info, and describe functions. As you can see, we have 5,000 entries and 21 columns in total. Also, this examination reveals there are some missing values in columns like date planted, plant area, and cultivar name. And describe functions showed the more comprehensive analysis of every column. So after this analysis, I was able to define which columns are we going to keep and which ones is better to drop because they are redundant or not relevant to my analysis. So I created a smaller data set to be more focused on the area of our interest. So I started from distribution of numerical variables across the categorical columns. So I created a box plot to analyze the distribution of such numerical variables as diameter and height range ID across categorical columns like neighborhood name, genus name, and root barrier. So you can see there are some outliers for different genera. There are some outliers in diameter and height range. So after this exploration, I figured out that tree diameters differ significantly between neighborhoods, and some neighborhoods tend to have higher median diameter with fewer outliers, indicating more uniform tree sizes. That different genera have very different diameter ranges. Also, the trees without root barriers are more common, and for trees with root barriers, there is a tendency to have smaller median diameters, possibly due to growth restrictions. That neighborhoods and genera with larger median diameters also tend to have higher height ranges. So potentially there is also a relationship between tree diameter and overall size. Also, I found some outliers, many outliers actually, in the diameter and height distribution, but this also requires further investigation, like to be able to define the reasoning. So then I moved to tree planting trends, and I used a line chart to visualize the trend over the years. Also, I created an even smaller data set for this because, as you remember, we have a lot of missing values in date planted, but I decided to keep this column because actually it's very useful to see like trends over time. So I converted date planted column to date time and extracted the year. So as you can see, this chart reveals a steady increase in tree planting activity from the 1991, followed by fluctuations in planting numbers in 1997-2014, and also there is a notable decline in planting activity around 2015. So it can be due to some changes in urban development policies, funding, or maybe some environmental conditions impacting tree planting programs. Additionally, these trends might also be influenced by how the data was collected. So we cannot make any insights like about this right now. It also requires further investigation. Then I decided to check tree planting activity across neighborhoods. For this, I used a phased plot. So as you can see from the visualization, some neighborhoods like Renfrew Collinwood and Hastings Sunrise, they have very consistent tree planting activity across years, and other neighborhoods such as Oak Ridge have limited activity concentrated in some years. So some neighborhoods have really inconsistent planting trends. So peaks in tree planting can be seen around 2005-2010 in several neighborhoods, highlighting potentially successful initiatives during this period. So the decline in tree planting post-2015 is evident in most neighborhoods, and again, there are some concerns about the reasons why it's happened. Then I decided to see the distribution of tree genus across neighborhoods. I used a heat map for this. And after investigation, I figured out that genera Acer and Prunus stand out as a dominant across most neighborhoods. And as we can see, it's a significant difference in numbers. So also I figured out that both of these genus are widespread, but their numbers differ significantly across neighborhoods. So after this, I decided to dive deeper into planting trends of Acer and Prunus, given their dominance. And I created another phase chart. So this phased plot revealed a steady planting pattern for Acer across neighborhoods. Also, we can see that Acer is much more widespread than Prunus. And Prunus exhibits greater variability with notable peaks in planting activity. Thank you for your attention.